Hello guys, today this video is about EIGRP routing protocol. And by the way, we know that what it is. EIGRP, it is nothing but enhanced interior gateway routing protocol, and we are having three major categories how the characteristic of the routing protocol will be. So for example, we know that there are distance vector link state routing protocol and hybrid routing protocol. So in that EIGRP will be coming under the hybrid routing protocol. Why? Because it is having the both features of distance vector routing protocol and also the link state routing protocol. Here we will be calling EIGRP will be working under autonomous system concept. So everything it is based on autonomous system, and also it is if we think about EIGRP, the very first point what it should come to our mind is the EIGRP. It is using the protocol called dual. Just a minute. Okay, fine. So EIGRP uses dual algorithm to perform some activity. So why we need dual and what it is dual? It is nothing but diffusing update algorithm. That is what the expansion it is. And why we need dual in EIGRP? Why? Because the dual algorithm help us to determine the best loop free path in the network. This is the first point. For example, what is a loop free? I think it is a simple word. I think don't know to explain it again. That means when we are having multiple path from source to reach the destination, we can tell a loop path, other closed paths. So, so from source, the data should reach the destination instead of rotating inside the network itself. That means it is not going to source or nor it is going to destination. It is not going anywhere. It is just simply roaming inside the network itself. So, in order to avoid that loop, here dual is algorithm which is taking place in EIGRP. And apart from that, it is also used to determine the backup loop free path. For example, there is a path 1 from source 1 to sorry, I have the path number 1 from source to the destination, which is a best path among n number of paths. Now what happen when my path number 1 goes down or due to so on so issues? It can be a circuit issue, it can be a link issue or interface, it can be down or erroring, whatever it may be. So when that link primary path it goes down, immediately it has to uh, the network should get converged. That means we should have we are having the backup paths, right? So again in that EIGRP it is going to check if I choose this path whether it can be a loop free or it may lead to loop. Okay, that it will be analyzed by the dual algorithm. If it is only loop free path, it will be taking. We'll see how it is doing that in detail in coming videos. It is a part 1 video, so it is more than enough. And as a last point I want to make a note is by using dual the network convergence will be faster. That means, yeah, whenever the path, that means let's consider the primary and secondary. When the primary path goes down, it needs to get converged with the secondary path so that our network availability is always there without having any trouble. Okay, so how much time it is taking to switch over from the primary path to the secondary path, it is called the convergence. So here it is taking place very fast when compared to OSPF and BGP. And here the EIGRP uses a metric is nothing but bandwidth plus delay. Actually it is a very complex metric what EIGRP uses. It uses both bandwidth and delay by default. Actually there are different parameters, k parameters we used to tell that. Well, after once I done with the configuration I will show you that parameters. And apart from that, EIGRP, how it is going to identify the neighbor. For example, in our diagram I have four routers. I'm going to run EIGRP in these four routers, and they are going to identify their neighbors by using the hello packets. Once I started configuring, once I done with EIGRP configuration, all my routers will start sending the hello packets on the interface where I have enabled the EIGRP. So that address, it will be a multicast address. Everything I will show you now. So let's get into the configuration part. This is what the topology you are going to see. Now I am the router one. I'm configuring loopback address. Okay, so I have done with the interface configuration in router 1, and all my interfaces are showing up and up. Fine. So I am ready to go to router 2. Okay. Loopback 0, IP address 2.2.2.2, 255, 255, 255.255. And then the interface I have is serial 0/0, IP address 10.0.12.2, 255, 255, 255.0. No shutdown. Interface serial 0/1, IP address 10.0.24.2, 255, 255, 255.0, and no shutdown. uh, Show IP interface brief. Yeah, so I had done with the configuration router 2 also. Let's go into router 3. I don't know why it is showing. Okay, so configure terminal interface loopback trio IP address 3.3.3.3, 255, 255, 255, 255. Interface serial 0/3, IP address 10.0.13.3, 255, 255, 255.0. No shutdown. Interface serial 0/2, IP address 10.0.34.3, 255, 255, 255.0. No shutdown. Show IP int brief. So we have done in router 3, and let's go to router 4. Interface loopback 0, IP address 4.4.4.4. Okay, interface serial 0/1, IP address 10.0.24.4, 255, 255, 255.0. Yeah, so I have done with the interface configuration in all my router. So let's go and configure the EIGRP. Here the autonomous system number, what I'm going to configure is 100. Okay, how to configure EIGRP? First I need to go to the global configuration mode, and I need to tell router you're going to run a EIGRP protocol, and the autonomous system number what you are going to use is 100. Okay, and under this I will advertise. Oh, okay, wait, I didn't do anything here. Okay, just I'm leaving like this. Just I have enabled EIGRP 100. Let's go to router 2 and let's enable the same thing. Router EIGRP 100. Okay, and router 3, router EIGRP 100. Okay, configure terminal, router EIGRP 100. Okay, show IP EIGRP neighbors. It will not show anything because you have enabled IP EIGRP for the under the autonomous system number 100, right? But you have three interface, that means two physical interface, one logical interface in all our routers. On those interface we didn't enable our EIGRP. So what are the subnets we need to advertise? For example, show interface serial 0/0. So under this interface we need to tell this interface is under the EIGRP process of 100. So how we will tell, either we need to advertise it. Okay, just a minute, I'll show you. So under router EIGRP 100 you can go and use the network command, and you can start advertise the IP, oh sorry, network of that interface. Why? In the sense you can show here, you can view here, show IP route. It will show you the connected routes. Okay, but it is not advertising anywhere because we are just running EIGRP 100. So we need to start advertising this connected routes. Okay, for example, in this router I have this many, that means 10.0.12.1 loopback 1.1.1.1 and one more interface 10.0.13.1, right? For example, okay, first I will advertise these three network, then I will come to this point. Router EIGRP 100, right? So under network I'm going to advertise 10.0.12.1, sorry, not 1, it is because I'm going to advertise the network. If you see, then it will be asking something called wildcard mask. It is not a subnet mask, so you should be very clear. Okay, so I have advertised 12 network and 1.1.1.1. Okay, and network 10.0.13.0 0.0.0.255. No auto summary. Okay, so this is what I have done under the EIGRP configuration, right? So on all these interface which is under this subnet, everywhere my hello packet, that is EIGRP hello packet, is going to send out. So the router who are the next side connected, once they receive these packets, hello packets, they will understand. First they are going to check these hello packets are coming from where. Okay, EIGRP routing process, and whether it is under which autonomous system number. If autonomous system number it is not matching, our neighbor relationship will not be established between the routers. So you should be very clear the AS number is same the two routers where you are trying to form a neighbor relationship.